Okay, so in this particular example, we want to know how is the volume going to change if the pressure changes and the temperature changes. And it doesn't say anything about the quantity of gas, so we'll assume that the container is sealed. So no gas is leaking in or out. So if we have some sample with a adjustable volume, so maybe this piston here can move up and down, but there's no leaking. And I'm going to increase the temperature by heating this sample up. The temperature is going to increase 3 times from what it was. And the particles, as a result of the temperature increase, are going to do what? They're going to move faster. Specifically, if I triple the temperature, they're going to move 3 times faster. Right? So they'll be colliding now with 3 times the force. So normally, a temperature increase that's a specific amount would cause a pressure increase by the same amount. Because the pressure is the result of those collisions, and if I have collisions that are 3 times harder, I should have 3 times more force or pressure related resulting from those collisions. But this tells me that the pressure is not going up 3 times. It's only doubling. So what must be happening to the volume? It's got to be going up, right? Because if I can say that if the volume doesn't change, and all I do is make things move faster and have 3 times the force, I should have 3 times the pressure. But if I don't have that much of an increase in pressure, that extra force that's due to the stronger collisions must be spread out over a greater volume. So the volume is going to have to go up. How much is it going to go up by? Well, we can use what we're going to talk about today, the ideal gas law, to quantify that. So the ideal gas law here, the reason we're kind of not focusing too much on section 11.4 is because any problem you can solve with the individual gas laws from 11.4, you can also solve with the ideal gas law. So why memorize 5 different gas laws when you really only need 1? So what's happening here is the number of moles, or the amount of gas, is not changing because the container is sealed. We're assuming that. And this R represents a constant number that's also not going to be changing no matter what. So if I rearrange the ideal gas law and get them on the same side, just divide both sides by the temperature, I've got PV over T equals a constant, because it's equal to N times R, and N is not changing in this specific example, and R is a constant, so it's not changing. So if those two are a constant, I can calculate what that constant is, or I can say that the initial pressure times the volume times the temperature will be equal to the combination of the final pressure times the volume times the temperature, because they're both equal to the same constant, which is N times R. And if N is not changing and R is never changing, then when I multiply P times V and divide by the temperature, I should get the same value. So whichever way I want to think about this, I mean, since I don't actually have numbers to plug in here to solve for anything specific, I just want to know how much does the volume have to change. I might have to kind of work this out, just recognizing that this is a constant. So if whenever I multiply the pressure times the volume and divide by the temperature from the ideal gas law, I know it's going to be a constant in this specific example. I can think about, well, what will happen if I increase the temperature 3 times? So if I multiply this temperature by 3 on the bottom of the fraction, and I increase the pressure by 2 on the top of the fraction, it's not going to give me the same constant anymore. So what factor does the volume need to change by in order for that to give me the same constant? Yeah, 3 over 2, right. So I've multiplied the top by 2 and divided the bottom by 3. That's going to, if I do that, it's going to change the constant, but that can't be because of the ideal gas law. If I want to keep it constant, what I need to do is that this needs to be multiplied by 3 halves so that the 3's cancel and the 2's cancel and everything gives me the same constant. So that means that the volume has to be multiplied. The new volume will be 3 halves of the original volume. So whatever the change in volume is going to be 3 halves or 1.5 times whatever it was initially.